Okay, so let's do a third and last slightly trickier example on adding force. And this time, let's flip the question around. Let's not, the previous two examples, we're given the forces and then finding the resultant force or finding the net force out of the two. What if we know the result and we want to find the original one? So let's flip the question around, and it's very physical. So here's a scenario. You can have an airplane, right? That's going to be my airplane. We'll work with that. It wants to go straight forward. Okay. However, there's wind, and this wind blowing, let's say 45 degrees this way. Let's label that 45 degrees, and it's blowing with 40 newtons. Okay. Now, which way should the engine, should the driving force or the thrust should be pointing at in order to go straight forward? Let's think about this, right? So if I have the thrust, let's call it T. Let's use driving D for driving force, even though it's not a car, but T sounds like tension. So let's use D. Going forward, what would be the resultant force? The resultant force would be, because the wind is blowing this way, the engine is making it go forward. So you want to move this vector or the way to here. By the way, yeah, you can do it algebraically, but if you want just a quick idea where it is, adding them geometrically is much quicker. But of course, if you need the numbers, algebraically is much easier to handle. Yeah, so I've moved the W, the wind vector over here. So what's the net result? If I can draw a thick one over here. So adding the driving force with the wind, my net force, well, let's call that the result, 10 force, right? It will be like this. Does that make sense? Yeah. So if I'm trying to drive it forward, but the wind is blowing here, it will end up sort of moving in this direction instead. Okay. So that doesn't work. Which way should I put? Can you guess? Which way should I point my my engine towards? Should I point it backwards? Well, obviously no, because if I point it backwards, then if I add it, then the result would be something like this, right? The resultant would be here. So you don't want to point your engine backwards. Since there's some sort of rightwards component, you better point your engine to counteract that. But not just like this, because again, these two arrows, you can kind of see that it will add towards this direction. Which is not what you want. You want it to go straight, right? So in some sense, you want it to be going this way, so that when you add this one, right? This one is 45 degrees, right? It's 45 degrees clockwise from the negative y axis. And so you kind of want to move this over here like this. So you know your result. You want your result to be going straight forward. You know the wind over here. It's a backwards problem of finding the driving force. So the driving force should be like this. Okay. So let's say the plane has an engine. The magnitude of the driving force, no vector sign, is 1,000 newtons, like this. All right. So the wind is 40 newtons. Can you find the magnitude and the direction? Well, the magnitude is fixed by the engine. Okay, can you find the direction that D should be, the driving force should be in? Okay, so how will we formulate this problem? Well, we'll set it up. The resultant, which is the net force out of this, is the driving force plus the wind force, right? So the driving force plus the wind force is the net force. Let's break them into components. Okay, so dx, dy, wx, wy, and rx, ry. Okay, you could write f net force, but like I said, I try to eliminate as much subscripts as possible. Okay, good. So here's a general problem-solving skill in physics. Write down what you know and try to work your way bit by bit through. So you take a complicated problem like this and try to simplify it block by block. Okay, so what do we know? Well, we know we know W is related to W, X, and Y. This seems to be the one that I know the most. So let's put that in. Let's put this here, right? So Wx is, let's try to do, now that you've seen two examples, let's try to do this directly on here, right? So that's Wx, that's Wy. Wx is the sine of 45 degrees because it's opposite, right? So that's 40, so that's W times sine 45. And the other one, Wy, is sandwiching the 45 degrees. So it's W, which is 40, but I just want to be clear. Also, this is another tip for you writing steps, for your quality of steps. If you want to write good quality steps, oops, sorry, that is too far up in the glare. I'll write it here. So if you want good quality steps, one way is to make sure your steps are traceable. When writing math or physics, it's important that the reader, as I always will mention over and over again throughout the course, the solution or the answer itself is the least of my concern. It's how you present and how you display your logical thinking. That is what is most important. So as you can see, it's very easy to follow this way and try to write it things flowing downwards instead of across, as you can see, because now I can match things very well. So this W vector is this D vector is this R vector is this in its component forms. And then now, if this is right underneath that, I can easily match Wx is equals to this, Wy is equals to this, as opposed to if I plug in the numbers too early, it might be tricky, right? So if I plug this in, I'll share with you some problem solving tips along the way as well during the lecture. Yes, it's kind of followable that this is 40 degrees, 40 newtons, but still Wx to here, there's so much going on. You want to display your steps almost like you're doing one thing at a time, okay? Each step should own, it's always a bad idea to do 2 or 3 things in one step. That's number one, it doesn't help you because it's more easier, you'll make mistakes. And number two, it's harder for the grader to follow. So if you made a mistake somewhere, you lose the chance of getting partial credits, right? If you break it down, you just do one thing per step. Yes, you write more, but you have more chance of getting partial credit. And there's more chance of the person reading it, i.e. the grader or the TA reading it, know what you mean, know what you're doing, and can actually give you points because that is the point of physics, to learn how to think and learn how to break things down. So it's counterintuitive. I always tell people, don't try to solve the problem in one step. That's where you get the least points. The amount of point is because so if you ever find that, oh, math is very intimidating, you have to think 10 steps ahead, you're in luck. The more you do it slowly, the more points you will get. And because that is how you train yourself to think logically. Okay, all right, so back to the problem. We have W here. So now it's more recently clear. You're showing exactly the relationship between W and Wx. Wx is basically W sine 45, and that's reasonable. Okay, so dx and dy, do we know anything about them? Well, we know that they should sort of Pythagoreanly add up to 1,000, but other than that, not much. So we'll put dx, dy over here. And on the other side, get a better pen. Do I know anything about Rx and Ry? A little bit, right? You might think you don't know anything, but you do know that you don't want any X component because you want it to be purely in the, did I put my direction somewhere? No. Right, so it's bad habit. Always good to have when you draw your diagrams, put a little compass, either northeast, southwest, or XY. If the problem gives you some northeast, southwest direction, you can use that. Otherwise, define your own XY grid. So I want no X components. I want it to be purely the result, right? The resultant force or the net force. I want it to be purely after you add up the engine and the wind to purely in the Y direction. So I want Rx to be 0. Again, it's very followable. So during the lecture, like I said, I'll tell you a lot about these problem solving skills and how to get partial credits and how to do well in the exam as well. Right? So Rx like this, okay? All right. Now, next step, again, what do I do with this? Well, write out everything you know, right? The W is something you do know. So let's continue with the next step. So that's 40 times sine of 45 and 40 times cosine 45. In fact, I will do this 2 steps together. I'm contradicting myself of doing more than one thing at the same time, but there's the only exception you can do this is for pure algebra. When you're substituting things, don't try to substitute and do algebra at the same time. That's usually a recipe for disaster. But here I am just doing one simple step. It's still very traceable. You can use your judgment with that. So sine 45 degrees is another very common angle. I happen to remember it. So it's 1/√2. It's the same as cosine 45 degrees. You can use the calculator and double check that. And before I do that, let's plug in everything else as well. dx, dy, and 0 and rx like this. Okay. Now, what does that tell us? Okay. Well, we can set up the equation over here. Let's actually get the concrete number. So let's do 40 divided by √2. And I got 28.28. So 28.3 roughly, right? So write up more steps. The more steps you write, yes, it wastes a little bit of ink, but it is much more preferable than if you don't. Okay, and the same thing over here. And quick check of your signs up to here. Should I put extra minus signs? So you need to look back over here. The wind is pointing in the positive x but negative y. So here, wy should be negative of whatever the number I get. Right. So as you can see, I always sort of do that in post, but don't forget to do that. Make sure you do remember to do that. Okay, and good. So I have 0 and rx like this. Okay, what can we do? Well, can you see something that's solvable? Because the first line looks like I can solve it. This means that, remember, you're adding things together, right? It means that 0 should equals to dx plus 28.3. And rx should equals to dy plus negative of that. So that's minus 28.3. What does that tell you? Well, that tells you dx should be, you guessed it, minus 28.3, sorry. Okay, good. What else? Well, to know the direction, I need to know both dx and dy, right? But I also know the magnitude is 1,000. Okay, so how can we use that information? Can you guess? Well, the magnitude is related to both dx and dy, so let's write that down. So d, or d square, right, is dx square plus dy square, right? It's always the components square, and you get the total magnitude square. So if I do know this one and I know this one, I'll be able to find dy. All right, so let's do that. But I'll probably skip right to the answer to save you a little bit of time. But let's just check if this makes sense first. So we have dx as a negative number, and if we look at the geometric diagram, does it look like d should have a negative x? Yes, it does have a negative x component like this, right? Okay, so we'll skip right to the answer over here. I'll write this down first. And that would be minus 28.3 squared plus dy. Okay, all right, be back in a second. Okay, there we go. So we immediately have, we can rearrange this and solve for this. All right, but we're asking for which direction it's going, right? So let's draw that out. So what have we found? We found dx and dy over there. So this means, well, we have this d vector like this, right? Let's draw out this. let's find out what direction should we tilt our engine at in order to go straight forward if there's a wind of 40 newtons of force that way. Also, dx here is minus 28.3. So this length over here, I know that's a negative, but basically the length of this vector is, or the x direction is 28.3, and over here is 999.6, right? Kind of makes sense. You kind of want the majority of your driving force to be going in the y direction, but you just want a little bit, just enough to counteract that little bit of wind that is dragging you to the right, right? So you want to tilt your engine to the left, but majority you want to tilt it so that it's aiming straight forward. Okay, so what's theta? Right, so we are almost an expert in doing this by now. We want tangent theta to be 28.3 over 999.6, and that means we can go forward, and let's skip to the answer again. Okay, again, we will have solved this. It's 1.62 degrees, but that's theta, right? So let's be clear as well. It's 1.62 degrees counterclockwise from the positive y-axis. And that would be the right answer. So what have we solved? We have solved that if there's a 40 newtons force of headwind this way, then we should actually not aim our engine directly forward, but just if we have 1,000 newtons of force, we should tilt it just a little bit counterclockwise, or in fact, just 1.62 degrees counterclockwise that way. Okay, all right, thank you. So hope this makes sense. And let me know if you have any questions.